Today we're going to look at another type of linear equation, but it's going to be in standard form. What standard form looks like is ax plus by equals c. So things to notice in that equation, we do still have an x and a y, just like in our other linear equations. So we've looked so far at slope-intercept and point slope. We have a, b, and c here, and those are just numbers is all they represent. So the a and the b are coefficients to the x and the y. So for example, down here in example A, we've got 4x and minus 2y. So those are just representatives of the coefficients of your x variable and your y variable. The c, however, the c is a constant. So notice there's no x or y next to it. So in these equations, we have x and y on the same side, and then we have a number by itself on the other side. So c does represent a constant in this example. Standard form equations can be super helpful if you're doing word problems or things like that, but for our purposes, while we're graphing, slope-intercept form tends to be more useful when you're trying to actually graph. So what we're going to do with standard form equations is convert them into slope-intercept form. So remember, slope-intercept form looks like this. We've got y equals mx plus b. So the big thing with slope-intercept form is that you need the y by itself. So what we're going to do for each of these problems is solve for y and get y by itself so that it's in a form that we would be able to graph if we wanted to or needed to. I'm going to do my examples over in all the blank space on my paper just because I tend to write kind of big, but I am pulling from just these problems over here. So that first problem in example A says 4x minus 2y equals 10. So we need y to be by itself. So I'm going to highlight that here so we can stay focused on that. And the way we're going to get y by itself is by using the same skills that we use when we solve equations. Those same techniques will work for solving this one for y. So first thing we're going to do every time is get the x away. We want it across the equal sign all the way on the other side. So if I want to move this 4x right here, it's a positive 4x. I'm going to subtract 4x on both sides of my equal sign. And when I do 4x minus 4x, it's going to go away. I've got negative 2y left over here. And then check out the right side. I've got 10 minus 4x. Those are not like terms, right? The 10 is a constant, and the minus 4x has an x in it. So we can't actually combine those. The other thing I want to consider is that I want it to look like this, where I have my x and then some number. So instead of trying to combine these, I can't combine them to a single term. I'm going to write the right side as minus 4x plus 10. So pause if that's blowing your mind right now. The minus 4x came from this piece. The positive 10 is where I'm getting that plus 10. And the reason I chose to write it in that order is so that the x comes first and then the constant, just like slope-intercept form. And now from here, I need to continue trying to get y by itself, and I need to divide by that coefficient. So when I divide by negative 2, I need to divide every single term by negative 2. And that, when I divide by negative 2 divided by 2, or negative 2 is just 1, so I'm left with 1y equals negative 4x divided by negative 2, and negative divided by negative is going to make a positive, so I've got positive 2x. Positive 10 divided by negative 2 is negative 5. And now this is in slope-intercept form, and I could graph that. So all of these are going to follow that exact same pattern. So let's jump on to example B. So example B says 5x plus 3y equals 18. And again, my goal is to get y by itself. So I'm going to start by moving my x's. Again, I've got a positive 5x, so I do the opposite. I subtract 5x to get rid of that on the left side so that I have 3y equals that 18 minus 5x. Again, those are not like terms, so I'm just going to write it as negative 5x since it was minus and plus 18. One thing you may be wondering, this plus sign in front of the 3y, same thing as a positive 3y is why I was allowed to not have to keep that plus sign. In the last example, it was a minus, so the negative is how that showed up when I continued. And so again, we're still trying to get y by itself. So right now, I have 3y, I mean 3 times y. We've got to divide by 3. Everything gets divided by 3. So that will get rid of 3y, so that I have just 1y. And then negative 5 divided by 3 doesn't work out nicely. It's going to give me a fraction. So I'm just going to leave it that way. Negative 5 over 3x. And then 18 divided by 3 is positive 6. So this would be slope-intercept form. And that would be super useful for graphing. I see my intercept, I see my slope, and I could plot that line now. All right, so this is where I would suggest maybe pausing. If you think you're getting the hang of it, you're welcome to go ahead and pause and try C and D. C is maybe a tiny bit different because we do have a negative 2x. So if you want to watch it first, that's fine, and then you can try D. So for example C, we've got negative 2x plus 5y equals 15. Trying to get y by itself. So this time, when I go to move the x to the other side, it says minus 2x, so I've got to do the opposite and add 2x on both sides. That's going to give me 5y equals, and again, I'm going to put the x first when I write this, 2x plus 15. They were both positive. And now, still keeping in mind my goal of getting y by itself, I'm going to divide everything by the coefficient by 5. And that's going to leave me with y equals 2 divided by 5, not going to work out nicely, so we'll just leave it as a fraction. 2/5 x, and then 15 divided by 5 is 3. One thing to note, your y-intercept for our purposes will usually work out to be a nice number, like a whole number, 3, something like that, maybe a negative number. But that's just so that we can graph it nicely. It does not have to be. It could work out to be a fraction or decimal, however you like to write it. So now if you have not paused yet and tried one on your own, do that for D. I'm going to keep going and go over it, but do try one on your own and see how far you can get. So in example D, we've got negative 3x plus 4y equals negative 16. So my goal, when I'm going from standard to slope-intercept, get the y by itself. And I do that by first moving the x to the other side away from the y. It's a minus 3x, so when we're moving across the equal sign, we do the opposite. So add 3x on both sides. We get 4y equals 3x minus 16. And still, to get y by itself, I've got to get rid of that 4 now. And since it's 4 times y, we do the opposite and divide by 4. We divide everything by 4. And we get y equals 3 divided by 4. Not going to happen nicely. So 3 over 4 x. And then negative 16 divided by 4 is negative 4. So a couple things I just want to revisit to clarify. The reason I'm always putting my x first as I start to solve is just to stick with the typical slope-intercept form that has the x before the constant. And then if another probably frequently asked question, I would say when we are subtracting, we're subtracting from each side. That division has to happen to everything to keep the equation balanced, basically. If we're going to divide one thing by a number, we've got to divide everything by that number. Whereas when we're adding or subtracting, we can write it once because it will still keep both sides of your equation balanced.